Welcome back, everybody. We're back at it with the superhero examples. Today we're going to be doing numerical statements, which I mentioned at the end of last video, which are different enough from what we are doing last time to just do them all together. Now, for the first time in a few videos, I think that everything we're going to do today, which isn't a lot, is actually pretty intuitive and easy to grasp. I'm sorry if it's not easy for you. I'm just making a general statement. I think this is easier than some of the other stuff we have been doing. So let's just get straight into it. We want to know how to translate three different types of sentences. We want to know how to translate there are at most sentences, there are at least sentences, and then there are exactly insert number here sentences. So we're going to start with our first example. There is at most one Batman. So how would we say there is at most one Batman? Basically, what we're going to do is because we want one singular thing in the universe to be Batman, we're going to introduce two universal quantifiers. We're going to say for all x, for all y. So for all x and then for all y. If x is Batman and y is Batman, then it must be the case that x is equal to y. So now what we have done is said that if we have two different things, if it's the case that we have two different things that are Batman, then they must be the same thing. Notice that there could be no Batman, right? Because that's what there is at most one Batman means. It means there's either one or there's none. So we didn't specify that there has to exist a Batman. We're just saying that if we find two things that are Batman, we didn't really find two things, they're actually the same thing. So that's how we would say there is at most one Batman. Now, what if I want to say there are at most two orange lanterns? This is where things are going to change a little bit. So we're going to have to introduce a third variable, a third universal quantifier. So I'm going to say for all x, for all y, and then for all z. And then this will be similar enough. We'll say, we'll use O for is an orange lantern, right? So x, and if x is an orange lantern, y is an orange lantern, and z is an orange lantern, here, let's just put that all in parentheses. Then, what's the case? Well, I have three variables here. And again, I want there to be at most two orange lanterns. So if I find that x, y, and z are all orange lanterns, then it needs to be the case that one of these variables is equal to the other one. And I have to cover all of my cases. So by that I mean I have to say x is equal to y, or y is equal to, x is equal to y, or x is equal to z, or y is equal to z. And that covers up all possible pairs of my variables being equal to each other. So I have to specify that this is the case. I have to say that x equals y, I'm running out of space, x equals z, or y equals z, close this off. So a little messy right there, but I mean, I explained it out loud. So that's what we would do, is we have to introduce these three variables when we're saying at most two, say that they all cover our conditions, so they're all orange lanterns, then it must be the case that a pair of these variables are equal to each other, and all possible pairs are x equals y, x equals z, or y equals z. And the same thing would continue if you were saying there are at most three blah blah blah. You would introduce four universal quantifiers and then say, oh, well, this must equal that and that. It gets complicated, but hopefully you get like the general idea. So those are our at most sentences, but what about the opposite? What if I want to say there are at least? Well, for our first example, this is going to be a very easy statement. If I say there is at least one Green Lantern, then what am I going to say? I'm just going to say there exists an X, there's something in this universe, and that's it. It's a Green Lantern. That's it. I didn't even need these parentheses. I'll say there exists an X, such that X is a Green Lantern, and that's it. Now, what do I do when I introduce two? What if I want to say there are at least two speedsters? Well, I'll have to introduce two existential quantifiers, so there exists an X and there exists a Y, right? So we have there exists X, there exists a Y. We're going to say that X is a speedster and Y is a speedster. And then because it could be the case that x is equal to y, we don't want that, right? We want there to be two unique speedsters. So what we have to say is, and x does not equal y. We have to specify that. So there's this thing x, there's this thing y, they're both speedsters, and we know for sure that x is not equal to y because these are two unique things in our universe, two speedsters. And there are at least two. So I'm leaving this open to there being more. So that's your idea for at least, right? And you could see how this trend would continue if you said there are at least three, there are at least four, blah, blah, blah. Now, what I want to do is say there is exactly. Now, what's another way to think of exactly, right? If you, I'm thinking in terms of math right now, right? So if I wanted to say something was equal to 3, if I said x is equal to 3, well, I could say x is less than or equal to 3, and x is greater than or equal to 3. And so it must be the case that x equals 3. Likewise, for it to be the case that there is exactly one Supergirl, there must be at least one Supergirl, and there must be at most one Supergirl. Then there has to be exactly one Supergirl. So that's basically what I'm going to do. I'm just going to conjoin my at least and my at most statements, right? So first what I want to do is say there is exactly one Supergirl. So I'll say there exists an X such that there exists an X such that X is Supergirl. So there's that. And for all Y, if Y is Supergirl, then it must be the case that X is equal to Y. Let's make sure we close up all parentheses. And there we go. So I said so the first part of this sentence says there is at least one Supergirl. And then the second part of the sentence says, and if we find any other things that quote unquote are Supergirl, they're not actually. They're just equal to X, which is our thing that is Supergirl. So we've said there are at least, and then there are at most one Supergirl. That means that there is exactly one Supergirl. And now, again, we're just going to extend this to the plural. If I want to say there are exactly two plastic men, I'm going to write this below the sentence because I think we might not have enough room to the side. So I'll say there exists an X and there exists a Y. All right. Such that, so we'll have X is a plastic man and Y is a plastic man and X does not equal Y. So there we go. I just said that there are at least two plastic men. That's not all I want to say. I want to make sure that there are at most two plastic men. So I introduce another variable and I say, hey, if this variable is a plastic man, then it's got to be equal to X or Y. So I'm going to say for all Z, if Z is a plastic man, then it must be the case that Z is X or Z is Y. And then I just close up all my parentheses, and there we go. It's a long, complicated way to say there are exactly two of something, and as you can imagine, it gets even worse when you say there are exactly three. But as long as you know the idea, as long as you know how to say there is at most and there is at least, and then know that saying exactly is just conjoining the two statements, you'll know how to do this. So that's all there's going to be for this video. I hope you found it easier than things we've done in the past. If not, again, that's okay. We all struggle. Just keep on practicing, you'll get it. But if you made it to the end of this video, thank you for watching. I really appreciate it, and I hope you learned something.